Hi, I'm Jamie.
Hi, I'm Jonah.
Hi, I'm Jeremy.
Although we love to exercise, we like our ice cream too.
And that's why we decided to do our chemistry project on ice cream.
And what better place to analyze ice cream than in Le Mars, Iowa, the ice cream capital of the world? Welcome to Iowa. Now that we're in Iowa, and Jess isn't here, let's burn the ice cream with fire.
No, we're not actually going to do that.
We're just going to test the freezing point depression of different types of ice cream.
We use 3 different types of ice cream.
I use Trader Joe's brand.
I used Haagen-Dazs.
I use Breyers.
This is the Haagen-Dazs ice cream. Starts with 0 teaspoons of salt, and it goes all the way to 6/4 teaspoon of salt. This is the Breyers, the water, and the Trader Joe's brand ice cream, and they all start with 0 teaspoons of salt and go to 6/4 teaspoons of salt.
As stated, we use 3 different types of ice cream to figure out the freezing point depression of each kind.
We took an ice sheet and placed 1 tablespoon of ice cream along with the inclining amounts of salt.
The salt will lower the freezing point because when salt is added as a solute, the entire mixture lowers its freezing point.
The first cube of the tray had 0 teaspoons of salt, inclining all the way to 1.5 teaspoons.
For each table, the column is exactly the same. It starts off with 1 tablespoon of liquid and has 0 teaspoons of salt. It goes again to 1 tablespoon of liquid and 1/4 teaspoons of salt. The liquid stays the same all the way through the column, but 1/4 teaspoons of salt is added all the way up to 1.5 teaspoons of salt.
We mix the salt and ice cream together using different toothpicks to make sure neither reaction is contaminated.
Once we put in each ice cream along with the salt, we decided to add a base of example water.
Once setup was complete, we put both trays into the freezer to let sit and the reaction to happen.
These are our results measured in minutes.
But before you hear our results, you should know that there were some uncertainties. We put our ice cream in the microwave for 30 seconds. This melted the ice cream just enough so that the salt could properly dissolve in it. Another uncertainty was that we each checked on our ice cream every 5 minutes to see if it had frozen. If we had kept an eye on the ice cream freezing progress at all times, perhaps we would have received slightly more accurate results, perhaps to the minute, or even the second.
These are the results for the Trader Joe's ice cream. The first cube froze in 50 minutes, the second cube in 55 minutes, the third cube in 70 minutes, the fourth cube in 75 minutes, the fifth cube in 85 minutes, the sixth cube in 90 minutes, and the seventh cube in 90 minutes as well.
The Haagen-Dazs ice cream had slightly different results. The first cube froze in 50 minutes, the second cube froze in 55 minutes, the third cube froze in 70 minutes, the fourth cube froze in 80 minutes, the fifth in 85 minutes, the sixth cube froze in 90 minutes, as well as the seventh cube that also froze in 90 minutes.
The first cube of Breyers froze in 55 minutes, the second froze in 60, the third froze in 70 minutes, and the fourth froze in 80. Next was the fifth, which froze in 85 minutes, the sixth froze in 90 minutes, and the last froze in 95 minutes.
The base of water was very interesting. The first cube froze in 45 minutes, the second in 55 minutes, the third in 70 minutes, the fourth in 77 minutes, the fifth in 82 minutes, the sixth in 95 minutes, and the final in 105 minutes.
So from this we can conclude that the more solute you put into the ice cream, which is the solvent in this case, the longer it will take for our beloved ice cream to reach its freezing point perfection. Oh, and by the way, that's right, we just stressed your system.
And we're the three best friends that anybody could have. We're the three best friends that anyone could have. We're the three best friends that anyone can have. And we'll never, ever, 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 ever leave each other.